National Electrical Code Section 210.52b3 requires all 125-volt, single-phase, 15 and 20 amp receptacles installed in the kitchen to be protected by a ground fault circuit interrupter, known as a GFCI. National Electrical Code Section 210.52b requires GFCI protection for receptacles installed outdoors, in bathrooms, garages, unfinished basements, crawl spaces, and other wet or potentially wet locations. Regarding the Nook counter outlet, it is not explicitly mentioned in 210.52b3 or 210.52b. However, an inspector may interpret the Nook counter as a kitchen counter that should be GFCI protected under 210.52b3, or as a wet location that should be GFCI protected under 210.52b. There are possible reasons for failure. Firstly, the Nook counter could be located near a sink or other water source, making it a potentially wet location. Secondly, the Nook counter is considered part of the kitchen and should therefore be GFCI protected under 210.52b3. Thirdly, a local electrical code may have additional requirements for GFCI protection in specific areas, including Nook counters. As corrective action, install GFCI protected outlets on the Nook countertop. Check with the local building inspector or electrician to determine if the Nook counter is considered a wet location or part of the kitchen for the purposes of GFCI protection. The importance of GFCI protection cannot be overstated. A GFCI is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. A ground fault occurs when electricity flows through an unintended path, such as through a person who is touching a live wire and a grounded object. GFCIs are designed to detect even small ground faults and to trip quickly enough to prevent serious injury or death. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC contains detailed requirements for GFCI protection in various locations, including kitchens, bathrooms, and outdoor areas. When installing or modifying electrical wiring, it is essential to follow the NEC and any applicable local codes. Local codes may be more restrictive than the NEC, so it is always best to check with the local building inspector or electrical authority to ensure compliance. In the case of the Nook counter outlet, the inspector's interpretation of the NEC and local codes is crucial. If the inspector considers the Nook counter to be part of the kitchen or a wet location, GFCI protection is required. To resolve the issue and pass the inspection, firstly, install a GFCI protected receptacle at the Nook counter location. This can be achieved by replacing the existing receptacle with a GFCI receptacle or by installing a GFCI circuit breaker in the electrical panel that protects the circuit serving the receptacle. Secondly, consult with the local building inspector or a qualified electrician to clarify the specific requirements for GFCI protection in the area. Obtain a written clarification or interpretation of the code if possible. Thirdly, if the inspector's interpretation seems unreasonable or inconsistent with the NEC, consider appealing the decision or seeking a second opinion from another qualified electrical inspector. When installing a GFCI receptacle, carefully follow the manufacturer's instructions and ensure that the wiring is correct. Incorrect wiring can render the GFCI ineffective or create a safety hazard. Test the GFCI receptacle after installation to verify that it is functioning properly. The test button on the GFCI receptacle should trip the device, cutting off power to the outlet. Reset the GFCI by pressing the reset button. If the GFCI does not trip when the test button is pressed, or if it trips immediately after being reset, there may be a wiring problem or a faulty GFCI receptacle. Consult a qualified electrician to diagnose and repair the problem. When installing a GFCI circuit breaker, ensure that it is properly sized for the circuit and that it is compatible with the electrical panel. Follow the manufacturer's instructions for installation and testing. GFCI circuit breakers typically have a test button that can be used to verify their functionality. Regular testing of GFCI receptacles and circuit breakers is recommended to ensure that they are working properly. Test them at least once a month, or more frequently if they are located in areas that are prone to moisture or humidity. The NEC provides specific guidelines for the location and installation of receptacles in dwelling units. Section 210.52 covers general requirements for receptacle outlets in dwelling units, specifying that receptacles must be installed so that no point along the floor line in any wall space is more than 6 feet, or 1.8 meters, measured horizontally from an outlet in that space. This requirement ensures that electrical appliances can be easily plugged in without the use of extension cords. Section 210.52b covers receptacle outlets in small appliance circuits. In kitchen, pantry, breakfast room, dining room, or similar area, the 2 or more 20 ampere small appliance branch circuits required by 210.11 cone shall serve all receptacle outlets covered by 210.52a. At least 2 small appliance branch circuits must be provided to serve receptacle outlets in the kitchen, pantry, breakfast room, dining room, or a similar area. These circuits are intended to supply power to small appliances such as toasters, coffee makers, and blenders. The receptacles connected to these circuits must be located within easy reach of the countertop. Section 210.52c covers countertop receptacles. In kitchen and dining areas of dwelling units, receptacle outlets for countertop shall be in accordance with 210.52 cone through C5. Receptacles must be installed so that no point along the countertop is more than 24 inches, or 600 millimeters, measured horizontally from a receptacle outlet. This requirement ensures that countertop appliances can be easily plugged in without the use of extension cords. Countertop receptacles must be located above, but not more than 20 inches or 500 millimeters above the countertop. This requirement helps to prevent spills and other hazards. Section 210.8 covers ground fault circuit interrupter protection for personnel. This section specifies the locations where GFCI protection is required for 125 volt through 250 volt receptacles. As previously mentioned, GFCI protection is required for receptacles installed in bathrooms, garages, outdoor locations, crawl spaces, unfinished basements, and kitchens. GFCI protection is also required for receptacles installed within 6 feet or 1.8 meters of a sink or water source. This requirement helps to prevent electric shock hazards in areas where water is present. Section 210.11 covers branch circuits. This section specifies the requirements for branch circuits, including the number of circuits required for different types of loads. As mentioned earlier, at least 2 small appliance branch circuits must be provided to serve receptacle outlets in the kitchen, pantry, breakfast room, dining room, or similar area. These circuits must be rated at 20 amperes and must serve only receptacle outlets. It's also worth noting that there may be additional requirements for GFCI protection in specific areas based on local amendments to the NEC. Local codes may be more stringent than the NEC, so it is always important to check with the local building inspector or electrical authority to ensure compliance. For example, some jurisdictions may require GFCI protection for all receptacles installed in dwelling units regardless of location. Other jurisdictions may require GFCI protection for receptacles installed in specific types of buildings such as apartments or condominiums. In addition to GFCI protection, there are other safety requirements for receptacles that must be followed. Receptacles must be properly grounded to prevent electric shock hazards. Grounding provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Receptacles must also be installed in approved boxes to protect them from damage and to prevent the spread of fire. Receptacle boxes must be properly secured to the wall or ceiling and must be made of non-combustible material. Receptacles must be rated for the voltage and current that they will be carrying. Using receptacles that are not properly rated can create a fire hazard. Receptacles must be installed in accordance with the manufacturer's instructions. Following the manufacturer's instructions will help to ensure that the receptacles are installed correctly and safely. In summary, GFCI protection is an important safety measure that helps to prevent electric shock hazards. The NEC requires GFCI protection for receptacles installed in various locations, including kitchens, bathrooms, and outdoor areas. It is important to follow the NEC and any applicable local codes when installing or modifying electrical wiring. The inspector's interpretation of the NEC and local codes is crucial in determining whether GFCI protection is required for a specific receptacle. In the case of the Nook counter outlet, if the inspector considers the Nook counter to be part of the kitchen or a wet location, GFCI protection is required. To resolve the issue and pass the inspection, install a GFCI protected receptacle at the Nook counter location and consult with a local building inspector or a qualified electrician to clarify the specific requirements for GFCI protection in the area. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electrical wiring, consult a qualified electrician. Electricity can be dangerous if not handled properly. Grounding is also an essential safety measure that helps to prevent electric shock hazards. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. All receptacles, electrical boxes, and metal parts of electrical equipment must be properly grounded. The grounding conductor must be connected to a grounding electrode, such as a ground rod or metal water pipe. The grounding electrode provides a connection to the earth, which helps to dissipate fault current and prevent electric shock hazards. Proper wiring practices are essential for electrical safety. All wiring must be installed in accordance with the NEC and any applicable local codes. Wiring must be properly sized for the load that it will be carrying. Undersized wiring can overheat and cause a fire. Wiring must be protected from damage. Wiring that is exposed or damaged can create a shock hazard. Wiring connections must be tight and secure. Loose connections can cause arcing and overheating, which can lead to a fire. Electrical boxes must be properly installed and secured. The electrical boxes protect wiring and prevent the spread of fire. The electrical boxes must be made of non-combustible material. Covers must be installed on all electrical boxes. Covers protect wiring from damage and prevent accidental contact with live parts. Overcurrent protection is an essential safety measure that helps to prevent fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current in a circuit exceeds a safe level. This prevents the wiring from overheating and causing a fire. Circuit breakers and fuses must be properly sized for the circuit that they are protecting. Using circuit breakers or fuses that are too large can allow the wiring to overheat and cause a fire. Arc fault circuit interrupters, or size, are a type of circuit breaker that provide enhanced protection against fires. Size are designed to detect arcing faults, which are a common cause of electrical fires. Arcing faults occur when electricity jumps from one conductor to another, creating a spark. A size trips the circuit breaker when an arcing fault is detected, preventing the fire from starting. A size are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Surge protection is another important safety measure that helps to protect electronic equipment from damage. Surges are sudden increases in voltage that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, power outages, or other electrical events. Surge protectors are designed to absorb or divert surges, preventing them from reaching electronic equipment. Surge protectors should be used to protect sensitive electronic equipment such as computers, televisions, and stereos. Regular electrical inspections are an important way to ensure that electrical systems are safe and up to code. Electrical inspections can identify potential hazards and ensure that electrical systems are properly installed and maintained. Electrical inspection should be performed by a qualified electrical inspector. The inspector will check for common electrical problems such as overloaded circuits, damaged wiring, and improper grounding. The inspector will also verify that electrical systems are in compliance with the NEC and any applicable local codes. It is also important to use caution when working with electricity. Never work on electrical equipment while standing in water or on a wet surface. Always turn off the power to the circuit before working on electrical equipment. Use insulated tools when working with electricity. Wear safety glasses to protect your eyes from sparks or debris. If you are not comfortable working with electricity, consult a qualified electrician. Electricity can be dangerous if not handled properly. Remember that the inspector's role is to ensure safety and compliance with electrical codes. While the specific interpretation of the code can sometimes be subjective, open communication and a willingness to understand the requirements are crucial for a successful inspection outcome. Document all work performed, including the installation of GFCI receptacles and any consultations with electricians or inspectors. This documentation can be helpful in case of future inspections or disputes. Finally, maintaining a positive and respectful attitude throughout the inspection process can help to facilitate a positive outcome. The inspector is there to help ensure safety, and working together can lead to a successful resolution.